Hey yo, so another video. This could draw, and I think the voice is good. So another video, another day. This could draw, and today, as usual, we're gonna solve some lead code problems. Today, the theme of the problems are about the queue. The queue is a data structure that is that's like the stack. And before that, don't forget to follow me on my social media account. You can find me on LinkedIn, you can find me on GitHub or on Instagram. And recently we created a Discord server, so you are free to join it. And without further ado, let's go to the problems. So before we solve the problem, we're gonna understand a little bit what is the queue in Python. So the queue is like the stack, but in the stack we have the LIFO, which is last in, first out. That means that the last element to enter the stack or the list is the first element to go out. But here in the queue we have FIFO, which is first in, first out. That means the first element that go onto the list, it's the first element that will go out of it. So if we enter from this side, this is the first element, it will go until here. So this the first element. We're gonna then, if you want to dequeue it, or if you want to pop it, we're gonna pop the first element that enter into the list. And for that we have pretty much two or three method, which is in queue. That means add an item to the list, and dequeue, it's the method that removes the item from the list. Let's just check if the video is going on. Can I just switch? Okay. And the queue is the method for removing the item from the queue. And that will have the complexity O1. Front is the front item of the queue, and rear is the last item of the queue. And to make this queue better, we're gonna use list, or we can use also the collection dequeue. So if you want to lose a list, there is two methods, which are append and pop zero. Append is the method to append the last item, and pop zero, it will pop the last item. Or we can simply use the from collection. We're gonna import dequeue. The import method is the same, but instead of pop zero, we're gonna use the pop left. And pop left will remove the first element that goes into the list. So this is our initial queue or list. So to insert element, we're gonna insert A, B, C. A, it's the first element to insert, and it will be the first element to dequeue or to pop. Okay, so and for the queue data structure, we have multiple methods. The max size, we're gonna return us the number of item allowed in the queue, and empty, we're gonna return us false or true. If the queue is empty, it's gonna return us true, and if it's not, we're gonna return us false. Full, we're gonna return us even. We're gonna check if the queue is full or not. Get, we're gonna remove us and return the item from the queue, and other method that we don't currently need. So this is another class. There is two classes, which are queue and collection. For the I will choose to work with collection. So without further ado, let's go. This a demonstration about it. So if we want to enqueue or to add an element, so it's gonna add to the list, and if we want to queue, then we're gonna simply to queue it. Peak is the first value, is empty. It's gonna check if it's empty or not. I have a job for you in the United States. Contact me after life. Hey, thank you, man. Welcome stream, by the way. And size. Hey, thank you. And size is gonna return the size of Q. So those are the methods that we talked about. So without further ado, let's go to this is my GitHub, by the way. I'd be so happy if you followed me on it. And now we're gonna start those two problems. And today theme, as usual, for the new ones, we divide problems by theme to make it easier. So today theme is Dota 2. This is a multiplayer game. I really didn't play it, but it's really famous. So we're gonna work on the number of recent cell and the Dota 2 Senate. So the number of cell we're gonna help us to the hero cooldown tracker. As support, you need to keep track of ability cooldown during the intense skirmishes. Determine how many abilities were cast within a recent time frame to decide your next move. And the fraction control area, we'll talk about the radiant and the direct fraction engaged in a strategic Sanoff. Use your vote to eliminate enemy senator and ensure your faction gain eliminate control of the Dota 2 Senate. Play wisely to outmaneuver your opponent. Pretty good, pretty basic. So let's go. We have the number cell. Okay, let's draw a little bit. This is the stack. Okay. I think that this. So here we have recent counter class, which count the number of recent requests within a certain time frame. Implement the recent counter class. Recent counter initialize the counter with 0 recent request. Int ping and t add a new request at a time. صح عليكم الولاد، والله صح عليكم. والله عرفت الرنين، اقسم بالله عرفت الرنين. رنين شارك في النايت بوت او قصته في الشات. So add a new resident time and return the number of requests that has happened in the past 300 milliseconds, which is a 3 second. Especially return the number of requests that have happened in inclusive range t minus 300 second, 3000 second actually, and t. It is guaranteed that every call to ping uses strictly large value of t than the previous call. Okay. So the example, we have two inputs which are recent counter ping. Every time it's gonna ping. So this is null 1, 100, 3001, 3002. Hey, hello, welcome stream. How you doing today? I'm fine. So we have recent counter equal new recent counter ping 1 is gonna return 1. So request 1 range is minus 2999 and recent counter So it's pretty simple. Okay, let's just divide it to smaller one. I find that too simple. Yeah, let's do it. So here get that way. Okay. So every time we're gonna append a or we're gonna ping a value, this value have to be in the range of the previous list. So we have here the list. This is null. This is 100, 3001 and 3002. So every time we're gonna ping. Okay, let's ping 1. The request 1 is a range. So the range will be t minus, like in the description, t minus 3000 and t, which is in our case here 1 minus 3000 and 1, which is minus 2099 and 1. And here our value, which is 1, is in the range. It's in the range of minus 2999 and 1. So we're gonna count 1. We're gonna count 1 plus 1, and we're gonna repeat that. We're gonna ping now 100 and calculate 100 minus 3000 and 100, which will be minus 2900 and 100. The previous value, which is 1, is included in this range, and the ping, which is 100, is included too. So we're gonna count 2, which are 1 and 100. So here we have 2. And we're gonna make the same operation. So this ping 3001. Now 3001 minus 3000, it's 1, and the range is 3001, and we have the list, the previous list, which is 100, and we have to add to it the 3001. Okay, so the 3001, all those variables are included in this range, so we're gonna count them, which are 3. Now we have to ping 3002. So 3002 minus 3000, it's 2, and here we have 3002. In this case, we'll have 1, 2, I mean 100, 3000, 1 and 3002. Now we have only three elements included in this range. So we will not count 1, so we will count 3. And now we have to dequeue this element and then return the length of the list. I think all is clear. Let's just resize this to make it clear. Okay, so the solution will be like this. We're gonna append until we will find a variable which is not in the list, And after that, if it's in the list, so we're gonna append it, we're gonna count it, and if it's not, we're just gonna dequeue it, and then or pop it, and then we return the len of the list. Okay, so let's do it. So here I'm gonna import the collection, and now I'm gonna initiate so self dot, we're gonna make it q equal q equal. Let me just check it. Q on Python. So none of this. Oh, DQ. Okay. So it is DQ. We're gonna import from collection, import Q. Collection is gonna import DQ and Q equal DQ. Okay. So now in every iteration we're gonna append the value. So self Q, which is T, dot append T, and then we're gonna make, I think, a while loop. So while self dot q, because we wanna assure that the queue is still full, it's not empty, and the number, or gonna t is in the range of no. So if it's not in the range, so we're gonna pop it. So it's lower than t minus 3,000. Okay, so let's just pop it. Okay, we're gonna pop everyone. While self dot pop left, I'm gonna choose pop left. So we're gonna pop it. Okay. And then we're gonna, after all this, we're gonna return the len of dot q. Like that. So it is returning so it is the wrong answer. Why is this? So I want to append t, and oh no, we don't have to pop it, I think. Okay, I'm just gonna I'm just gonna see the element. I'm not gonna pop it. Oh. Oh, that's correct. Hell, man, what's the time? 20 minutes. No, actually, it's 10 minutes because we only started at 10. Man, oh. Yeah, it's easy, but man, come on. Okay, so we are like the all other solutions. Let's see other solutions. 5 solution, 3 map, set. Okay, 3 map. Oh, that's crazy. It's really crazy. Linked list. Well, I think the queue. Yeah, the queue is the easiest one, and it's like the same one. Okay, so problem 1 done. Let's go to the problem 2. It's Dota 2. I really didn't play that game, but I hear it's really good. I think it's like League of Legends, but the new League of Legends. Okay. The description is little bit too long. Okay. I'm not gonna do anything. So, in the world of Dota 2, there are 2 parties. There are Radiant and the Dire. Okay? The Dota 2 Senate consists of senators coming from 2 parties. Now the Senate want to decide on a change in the Dota 2 game. The voting for this change is round-based procedure. In each round, each senator can exercise one of the 2 rights. Ban one senator's right, a senator can make another senator lose all his right in this and all the following rounds. Announce the victory. If this senator found these senators who still have right to vote or are from the same party, he can announce the victory and decide on the change in the game. So given a string, Senate representing each senator party belonging to character R and D represent the Radiant party and the Dire party. Then if there are n senators, the size of the given string will be n. Okay. So the round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the ending of voting. All the senators who have lost their right will be skipped during the procedure. Okay. So suppose the senator is smart enough and will play the best strategy for his own party, predict which party will finally announce the victory and change the Dota 2 game. The output should be Radiant or Dire. Okay. So let me just make it clear. Every senator is gonna ban another one. And it will be from different party. So the Radiant will ban the Dire and the Dire will ban the Radiant. Okay, so and the victory will be announced only if senator found the senators who still have right to vote or from the same party. He can answer. So we will end up by we'll have to end up by only a list that have Radiant or only a list that have Dires to announce a victory, the victory of one of them. Okay, so okay, so let's look at example. So how we have one Radiant and one Dire, and the Radiant will win. Why is that? So the first senator comes from Radiant, and he can just ban the next senator. Okay, let's just make it like this, and here we have this. Okay, let's draw a little bit. So I have now in this meeting we have R and D, which is radiant and dire. So the first senator comes from radiant and he can just ban the next senators right in round 1. Okay, so the radiant now will ban the dire in round 1. And the second senator can't exercise any right anymore since the right has been banned. Okay, so we're gonna loop from the left to the right. The first one is the radiant will ban the dire, and then the dire cannot exercise any right anymore in round 2. Oh, so we're gonna loop again. Okay, so we're gonna loop again. The first senator can just announce the victory since he is on. Okay. So I think here, okay, I think this is clear. So now we have a FIFO. We're gonna paint radiant. We're gonna paint dires. So the radiant will delete or pop the dires. Okay, and then we're gonna see the what left in the queue. So it is left only for radiant, so the radiant will win. Okay, so another example. Now we have R, T, and D, and the dire will win. Why? Okay, the first senator comes from radiant, and he can just ban the next senator right in his. Okay, so the radiant will ban the dire. The first we're gonna loop. We're gonna loop from this side. The radiant will ban the dire. And the second senator can't exercise any right since he is banned. Okay, the dire can't exercise his right. And third senator comes from dire and he can ban the first senator. Okay, so we're gonna loop it. And this dire will ban this radiant. And since there is only one dire left in the queue, so the dires will win. Okay. So I can think of queuing them into one queue, or queuing them into one queue. Okay. Ah, man. So this is our queue. We have R and we have D and we have D. Or should, okay, this is, we're gonna insert it from this and we're gonna delete from this. Okay, so this is cool. So how we're gonna know it now? So we're gonna loop through it, I think. If we found a dire, a radiant, then we will delete a dire. Oh no, we have to delete the one next to him. Doesn't matter even. Doesn't even matter. So what we have to do is I'm gonna ban this and okay, and then no, but then we have to increment it and go to the next one. If we have dire, then we're gonna delete the, but how we're gonna delete it? We can't simply delete it in the queue like this. Okay, So can we think of another approach? It's not one queue, it will be two queues, I think. So the first queue will be for radiant, and the second two the second queue will be for dyers. So this RD and this DR. Every time in this we're gonna append. So all the type of the element in this list or the queue are all R or all radiant. So we don't need the type, but can we insert the index? Okay, let's insert it. So how we have 0, so we have a radiant in the index 0, and we have a dyer on the index 1 and on the index 2. Now we have to make two pointers, I think. So this is E and this is G. If you find a radiant, then we're gonna delete the dyer next to it, which is the first element, which is 1. Okay, that's cool. And then we increment. No, we don't need to increment. It will be deleted, so no, it will not be increment. This is the first one to enter. Oh, so okay, so it will be the first one to okay, that's cool. And then we have a dyer, okay, and then we have the dyer. This dyer will delete this radiant, but why the radiant? How are we gonna tell him why the radiant is not deleting the dyer again? Hey chat, you can type Discord like this to see the link of the Discord server. I think the Nightbot, yeah. So the Nightbot is working very well. So you can type Discord to see the Discord link, and feel free to join us anytime you want. So let's continue. Yeah. And thank you very much for that tutorial. Thank you very much. So how are we gonna turn? It is like the lower the index, we're gonna compare the index. If 0 is less than 1, so the 0 will delete the 1. Yeah, okay. In this case, yes, but okay, so 1 is greater than 0, so it's gonna be deleted. But now the 2 have, oh, so we will loop it again. But how do we know? Oh, I think if there is no more radiant, then the now is the dyer's role. So we have actually two conditions, I think. Okay. Can we write something? Okay, let's just write some. So, okay. Let's just the outputs. The outputs. Window outputs. So something like this, and let's make it like this. Or you know what? Let's just expand it like this. Okay. So now we're okay. So now we have, I think, two conditions. So we're gonna loop through the list and see whose role is now, which is radiant or dars. Okay, so it's a little bit, and then if the one who have the lower index is gonna delete the greater one. So if the radiant have index have a less index than the dires, then the radiant will delete the dires. Okay. And then we have to loop it again if there is no more radiant or there is no more dires. Okay, so we have to loop, but we're not gonna loop the list, do we? We don't need to loop the list. No, we're not gonna loop the list. We're gonna loop the queues. Through the queues. Oh no, we're not gonna loop. We're gonna see what queue it is empty. See what queue. No, but if the queues are empty. Okay. So if one of the queues are empty, the other will wins. Okay. See what queue is empty. So the other team will win. If the dire queue is empty, so the radiant will win. So this is a return. I'm gonna return this. And now for the loop again, if they are not the two empty, so if the two queues are not empty, so yeah, it is really hard actually. I don't know how the lead code is given the type of the problem. Is it medium or hard? Because I think this is a little bit hard. I don't think it is medium, or I am easy. I am actually weak. if this medium I am weak. So if the two queues are not empty, no, no, this is not the case. The two then, how we gonna tell them? I got cooked in that exam yesterday. Hopefully, I think passed the exam. Oh, this sad, man. But yeah, you got it. It's one exam. You can do better than the next ones. So welcome stream. Hey, welcome stream. So what do you mean by app development? Is it like a mobile app or a web app or? I think I can work web app, but by the way, in which year are you, my friend? So I'm currently in second year of software engineering. I have only one year left to graduate, and yeah. So if the two queries are not empty, no, how are we gonna loop it again? So if we have, so let's suppose that this is the one. If we have, this detail is, I think the old problem is good, but this detail is a little too tricky. Okay, fuck it. Let's go. So yeah, mobile app Xcode Swift. I really I will study this in the second semester. I will study Flutter or React Native, but right now I'm not that good in it. So I think we better start coding. Okay, so let's make this one and make this one. Okay, so let's go. Okay, so first thing, we're gonna loop through the list and see. Now we have to initialize the queues. So first we're gonna import. Is it? Yeah. Okay. So the queue. So we're gonna make two queues which are RD and DR. So RD equal DQ and dr equal dq, and then we're gonna make senate into a list and loop it and insert every element. So I'm just gonna make it list equal list of senate, and then for in, oh, we need the index. So we're gonna use the enumerate function in Python for eg enumerate. Is it correct? So it is enumerate. So eg enumerate L. We're gonna append in RD if so I is the element and G is the index, right? So okay, the first element is the index, and okay. So if G equal R, then we're gonna return then we're gonna append to ld, so ld dot append I, which is the index, and return append. We're gonna append to the other, so dr dot append I. I think we're cool now. Okay, so now we have the two queues initialized and we insert all the element. Now we have to okay, we're gonna make a while, and if one of them is empty, then we're gonna return the other. So man, you motivate me to study DS. Me too. I'm also but in my course of CS for your course, you may also. Hey, it's good to hear you, man. It's good to hear that. Yeah. So good luck with the journey. It's really not. It's not hard, but it's not easy also. But it's possible. I am a normal dude in my second year of software engineering, and I think I can do it. So you can too. Yeah. Best of luck, man. So dr.append. This is why you should like the stream. Yeah, you should like. You should like and follow and subscribe, man. So what did we say? So while okay. So that's while, and after the while we have to after all this, if dr is empty, I think there is empty. Okay, let's just say dr is empty. Then we're gonna return the return radiant. What is the output? Okay, radiant. Just copy it. And if not, I'm gonna return dips. Shouldn't you have okay. No. Okay, the whole process and the whole approach is gonna be in this while loop. So while none of them is empty, so while okay, so why this is always like this? Okay, when not and or let me go. Hey, thank you, man. Thank you. Appreciate that. And not the other one too. What we gonna do? Oh man. Yo. Okay. So what we gonna do? So the one who have the lower index is gonna delete the other. So we'll check the we'll check the first element of every DQ. So if dr of 0 is lower, okay, is lower than RD of 0. And there is no equal condition, so will be else. If not, so the lower one will delete the greater one. So we're gonna pop from RD. So RD dot pop left. Else we're gonna pop from the other. Okay, so until this I think we're good. Okay, I'm just gonna run and see what is going on. So okay, collection DQ has no, oh, so okay, I'm just gonna use them. Okay, if while len of the isn't equal to 0, or len of RD the Q index out of range. Oh, it's about 52 minutes. Okay, so what's the problem here? Okay, I'm gonna check for this. I'm gonna print the air and print RD. It's gonna see them. Okay, so the Q1, can't I just print them like this? Oh, so print list. Okay. Okay. So we'll make them a list and then print them. Okay. To see their content. Okay. What the fuck? Hey, how are you, man? Welcome to stream. So R&D. Oh. So this test case is good. Oh, yeah. Okay. So we have now R and 2D. Okay, so we're good. Okay, we're good. We're good to go. So, and then after that, okay, there is something on this. Out of index. So if dir of 0. I want to know the this element and pop. So just want to know the top element. Okay, so no need. So I'm just gonna ask. So I'm just gonna ask a chat for a thing. Okay, so don't correct nothing. I'm not gonna correct anything. I'm not gonna complete anything. I'm just want to know what's the error. Don't line, which line? Let's learn. So there is a error line 15. Okay. So there's a line 15 dot index out of range. What is it? So the error you're encountering late because the issue is comparison first element. The line is compared the value which are indices. They're also potentially encountering the index of the range. Become empty before the loop finishes. But I have a while loop. Is not correct. While I'm okay. So while yeah, that's it. Same error, man. And if none. Yeah, okay. Okay, but still it is not doing that much. Don't know what is happening right now. So why is he not okay? So Okay, still not working. Still same error. This. Okay, like this is what I'm writing right now. Oh, okay, so the first test case is good. Okay, we're doing a progress. So the first one is good, and the second, so the second one misses one thing, which is the approach for the looping again. So we're right here, right now we're not looping again. Right now the radiant, the diodes are deleting the radiant. So how we're gonna do it? So I think this is okay. So the 0 is deleting the 1 and the 2. Or should we pop the 0 also? Oh, okay. Okay, okay. So we should pop. Hmm. We should pop the 2. Okay, so we should pop the 2. So we should pop the 2 to get rid of that 0, and we have only the 2 is okay. So for but okay, so in that case we pop the 2, and so in the two cases we will pop the 2. Oh no, the 2 has to pop the 0, so I don't have a particular solution in my mind actually. Oh, can we add this, the length of this, so he becomes more. Oh, so he becomes 3, and then the 2 can. Okay. So every time we will compare this, we will add to it, to its index actually. So RD, so dr of 0 will be plus equal len of the other 1 plus 1. Yeah, plus 1. Yeah. So the d are d plus 1. Okay. And also this, I think. Now I have to and the air. Okay, let's test it. Okay. So I want every time to print those two lists. Hey baby, come on me. So, and that, now we have this is dr and this is rd. So 1 2 and then 1 2 and then 2. So 1 2. Why didn't he do anything? dr 1 0 1 0. Okay. So okay. So let's make it here in the list. Okay, so 1 2 0. Now the 0 should delete the 1 and become 3. He has to become 3. Oh, he has before he has to make it before. So I think that's good. Man, what's going on? So the 0 deleted the 1 and then become 2. And okay, this case is good. So the 0 deleted the 1 and then become 3, and the 2 should delete the 3. Oh, wait, it's 4 here. The 2 should delete 3. Okay, so she deleted it. Okay, so she deleted it, and then this is empty. Nah, man. Nah, you're joking. The term is not good. Okay. Oh, I think we got it. Okay. What gonna do? Okay. So we have 2 deer and 3 radiant. So deer radiant, so 0 1 0 1 2 3 4. Okay, so the 0 now will delete the 2. Okay, and become 3. He become 4. He should become yeah, 4. What's 4? He should become the plus the last one. Oh, so the R of 0 will be RD minus 1 plus 1. RD minus 1 plus 1. Okay. And dr minus 1 plus 1. Okay. Yeah, I'm so close. I'm so close, man. Yeah. Okay. So the 2 test cases are good now. still the statistic case is not good. Okay. Man. So we have the 0, 1, 2, 3. The 0 deleted the 2 and then he became 5. Okay, so 5, 1. Then the 3 should delete the 5. Okay. So 3 should be and become 5. And 1 should and 4 should need I'm not understanding now. So let's draw. Okay, so we have two things. So this is dr and this is rd. So in dr we have 0, 1, and in rd we have 2, 3, and 4. Okay, let's check it. So the 0 will delete the 2, so the 0 will delete the 2 and will become 5. Okay, will become 5. And then the 1, we're gonna go to the next one. Okay, so the 1 will delete the 3 and will become 6. Okay, and now the 4 will delete the 5. Okay, and then 4 and 6, the 4 should delete 6. Okay, so what's the thing? So the deer will delete the and then the deer will delete this, and then the radiant will delete this. Oh, and then the deer will delete the radiant. Okay, but why this not? I really don't know what is happening right now. So it really depends on this, what we're gonna add here. So the video, I think it's too long, so I'm gonna just ask chat for those two conditions. So I have a little issue. That's correct. So in the two condition, no, the assertions 17 and 21. 17 and 21. What to Okay, so the issue you're facing is with this. Okay, so the dr inside the loop is not quite right. Intention. Only the battle between. Should be appending the current generator to the back of the respective TQ. And get hold again. Oh, okay. Okay, so we move it to the back, not just increment it. Okay, move it to the back and then okay, so So if you move it to the list, then he will vote again, and we don't need that. We need that he move to the back. Okay, so I think this is it. So let's just change that and change this also. So RD. Okay. RD book lift. Okay. RD and RD. Oh man, what? Wait, why it's too? Can I just copy it? What's the issue? Did he do something else? What did he do? Okay. So the thing was, in this instruction, it is the most important instruction in the problem. So if you want to make the this senator, if you want to make this senator vote against it, you have to increment its value by the length of the party, of all the people there, and then you're gonna append it. Okay, you did it. Freedom at least. Well, ChatGPT helped me a little bit, but the whole approach, the whole idea, it's me. So I think we're good. So yeah, but it was really nice. This code problem. I just want to see what other did. So okay. So the same approach. Yeah, the same approach. Okay. We're good. Okay. Fight. Yeah. Fight. Okay. And every time he's fighting or he's deleting one, he's incrementing all the indexes by or values by the length. So we're good. There is no Python thing. Okay, so here's it. Append pop left. Okay, so he's gonna pop it. Either way. So I think this is the end of stream. This is the end of video. Thank you everyone. And as usual, we're gonna meet tomorrow, hopefully. Thank you all for the support. Thank you for subscribing. Thank you for watching us and commenting and helping us reaching other people. I hope that this channel is not only benefiting me, it's also benefiting you, inspire you to do the same. Good night. To do the same, to grind lead code, to pass your limit. Thank you all for the... Hey, hello man, welcome. I am from Tunisia. To do the same, to pass your limit, to be better developers. And think we will meet again tomorrow at the same time. So see you tomorrow.